So I bought this piece of junk at the first ham radio flea market that I ever attended in 1991, I think it was. And, well, it never worked properly since the day I got it. The batteries didn't work. The batteries were leaking. It just was intermittent. Sometimes it would work, sometimes it wouldn't. I took it apart, but never got around to fixing it. Let's take a look at what I got. This is a frequency counter that I've had since, I don't know, forever. I don't know when I got this thing. It used to have batteries in it. I don't think I've ever shown this thing before to anybody, but it doesn't work, and it might be one that's repairable. I bought this at a ham flea market, I think 1991. I don't know who built it, or even if it's a commercial product. Looks kind of like somebody may have built this thing. May have been part of a kit or something. But anyway, it's a 1.4 gigahertz. Goes 10 hertz to 50 megahertz on one, and then 50 megahertz to 1.4. So it's got a prescaler on here, and you select your prescaler or direct input, and the gate select, slow or fast. And where's the power button on this thing? Used to have a battery in it, but the battery went bad. And I don't remember the last time I used this thing, but it always had a problem. It was always intermittent. Like it was. It's probably where these edge connectors connect. Is more than likely where the problem is. But this thing was always a piece of junk. Like it always gave headaches. Just looking at the board here. So US 1. This looks like this was probably a kit. It's got hot snot holding it together. But I think this probably was at some point was a kit and somebody built it. But let's see if it works. It's got heat shrink tubing on it, so I must have had it connected to something, to a power supply of some type at some time. I actually started to repair this one, and then something came in and I stuck it back on the back burner. I don't even know if I've ever looked at this on camera before. I just did a quick search to see if I did a video on this, but no, I don't see anything showing up that indicates that I've done anything. So I think maybe I had this hooked up to a power supply at one time, and it was cut off, and the power supply was robbed for something else. So let's just reconnect it. I think it runs on 6 volts. 6 or 12 volts, I don't know. It's got a regulator on board, but let's just see when I hook it up whether it does anything. Does anything light up? It does light up. Okay, it's got numbers flashing all over the place. They're not very bright, but I don't know if it's working or not. So I guess what we need to do is put a known frequency into it, such as from my audio generator, and we'll see whether this thing's working. I remember it had a problem, so I don't remember what the problem was. Like maybe it didn't count? I think that might have been the problem. Possibly. But it'd be nice if it worked. I could use it for testing speed and so forth of tape decks, as opposed to having to use my scope. Well, this piece of shit. It did have a problem. And I let's see if we can figure it out. It's probably a connection along here, because I remember it was cutting in and out. Now it's just flashing random numbers. Yeah, that's pretty normal for this thing. It just picks up random signals out of the air. Well, it sure isn't working. I am giving it a 400 hertz sine wave now, and it's not displaying anything. It's just jumping all over the place, as you can see. So let's see if we can figure out why this device is not working. Let's trace where the signal goes. Signal does come into the front board here where it's buffered, and then it goes from there up to the main counter board. So something in here could be bad. What do we got here? I'm thinking a connection is what I'm thinking. But let's get the scope going and see if we can track down where we're losing the 400 hertz signal that I'm giving it, because it should be detecting this. It should say 400 right on here. Okay, if I measure my input here, I have 400 hertz exactly on my digital scope. 400 hertz. So now let's just track where this goes. I'll get my light on so I can see the path that it takes after it goes in through here. Is this a double-sided board? No, it's not. So after the signal goes in this way, it's got to go .400 hertz there, 400 hertz here. It goes through this capacitor here, and this squares it off, so it's clipped, and it goes in through the transistor here. Is this amplifying it? Okay, I've got a lower signal here, but it's clipped to a square wave at 400 hertz, so it's been clipped. And it's much lower in signal. From here it goes to here. Those black wires that you see sticking out there, those used to go to the switch. And the switch was on the back of the unit, and I obviously needed the switch for something, so I just cut the switch off. Another capacitor here, and it goes down. It ends up down at this board, down at the end of the board here. So I've got it there. So yeah, I cut that switch. I needed it for something, and then I just bridged it on the top so that the thing's got power as soon as it's powered up. Because I wasn't using this thing. I haven't used this thing more than a couple times since I wasted too much money at a flea market to buy it. It should be going up to the main counter board on one of these terminals up here. I learned pretty quick that, yeah, you can get some good deals at these flea markets, but which I see nothing. Most of the stuff is grossly overpriced junk, and that's why I avoid them today. I'm not showing you guys the scope, but you'll have to take my word that there's no signal. There's no signal coming up on any of these. So that would certainly explain why it's not working. Let's do some continuity checks. See where we're losing. So you'll hear it beep if I've got continuity. Let's just see whether I've got continuity through these pins here. So this first pin, I'll just test it to this side of the board here. Oh, there's nothing there. Well, that might be the problem right there. Let's check the second pin. Does it have... Second pin has continuity. How about the third pin? Third pin has continuity. It might be this first pin right here. Nope, wait a minute. Nope, I got continuity now. Why didn't I before? Okay, that does have continuity. Soldering on this is kind of atrocious. Yeah, especially that big blob where the power switch used to be, right? But we won't talk about that one. I'm talking about the rest of them that are atrocious. I wonder if this pre-scaler select switch is where the problem is. That side's good. Okay, here's that was the attenuator switch I was looking at. This one here is the prescaler. And a little switch there. When it's flipped to direct, it should be the center to the contact on this side that's connected. Okay, now it is. And this one over here. If I flip the switch the other way, it should go the opposite direction. It should be to this one. And this one here. There's one connection here that, no, it looks kind of maybe a bit questionable on that switch. I'm just going to reheat that. Take a look. This is the one I'm talking about. Right down here. See? That one right there. That is kind of... Well, I mean, there's a lot of connections on this thing that don't look to be done that well. That look like they could have been, you know, done by an amateur. Like all these ones down in here. Look at the flowing of the solder down here. I get the sneaking suspicion that this was definitely a kit that someone put together. 1989. You know, it probably came out of a magazine, I'm thinking, and someone built it.
Back in the day, we had magazines like Radio Electronics that would publish kits complete with the printed circuit board layout that you could just photocopy it onto a transparency and make your own board. And I think this probably is where this came from.
Corrosion on this resistor. I don't think that's going to be affecting it though.
I mean, I could be wrong. It might have been a commercial product.
I bought this thing at a flea market and never really used it a heck of a lot because it never really worked properly. It was acting up from day one. The battery wouldn't hold a charge. It was a nickel cadmium battery that was in there. Battery wouldn't hold a charge.
You know, typical hamfest home-built crap. There's a lot of that out there back in the day.
I think a bunch of us got burned. A lot of people get burned at ham radio flea markets. You know, when you're newly licensed and you're all eager to buy equipment and you head out to these flea markets and you see all these great deals and you buy stuff from people that you don't know. But you trust that they know what they're doing because after all, it's hams that are there, right? They're all going to be good. But so a few people got stung at flea markets.
I remember I also bought a repeater. I was going to set up my own repeater. Yeah, right. It was a pie. And there was nothing that could be done.
Interesting. The red wire just kind of ends. It's connected on the board here, but it doesn't go anywhere.
Eventually we did get that repeater running and got it on the air for a while, but man, I could have built the thing from scratch rather than starting out with the abortion that someone else sold me.
I think I'll touch up some of these connections in here and see whether there's anything different. I figured I'd use this little DC powered from my 24 volt DC supply soldering iron on this one. Seems to have fairly accurate tip temperature, but it's a very fine tip. And when you're working on these fine electronics, fine points, and a fine tip might be something to my advantage. The lands on this board are not very big. You can generally tell when someone's, an amateur's made a board, just because most commercial boards would have lands that were bigger than this.
I mean, this one's definitely been hand built. There's no question. Just looking at the way it's laid out, that this wasn't wave solder or anything. This has been hand done. Of course, the big question is, after putting in this effort, is it actually going to work? Because at this point, I'm not holding out much hope at this point.
There's a surface mounted cap there going to that preamp transistor.
Watch this one closely. There is a break here. I'll bridge over it, but that trace does have a break on it, and that's why when I first measured it, it measured open. It's right where my tip is right now. There's a break right there. You see it? It's open. You can see it. I have to bridge back over there. There is a break there. That's why when I first measured that, it measured open, and then when I measured it a little bit further down, it was fine. But that may be where the problem is, right there. Well, that's one of the regulator is also really bad. As you'll see, it's almost falling off the board. But it certainly needed some reworking, that's for sure.
My roll of solder is starting to get kind of small. I'm going to have to get some more before I know it. I'll be out of it.
this has got to be one of the dumbest ways to connect two boards. I mean, come on. Put a header and a plug. So you plug it in and you've got a good connection. This is a Mickey Mouse way of attaching two boards if I ever saw one.
I think it's going to be one of the worst ways to interconnect anything, doing this. Butting two boards together and just using the solder to tack them together is just a stupid, cheap way of doing things. Looks like somebody's made some modifications on here too. Cut the traces, or cut a trace back. One connection that's definitely bad is this regulator. See it moving there? We'll just redo that one, that's for sure. My negative wire also pulled out of the board because it's solid wire and it wasn't soldered in very well. I guarantee you this problem is this is solder related. I'll just use my other arm because it's a little bit bigger tip on this one. A little more heat. We'll redo this wire here if I can without it falling out.
It's solid wire too, right? The sign of an amateur. Use some bloody flexible wire on things that can get bent. The solid wires for the birds. You bend it a couple times and it breaks.
I'm almost tempted to put a bridge wire right across here just because this trace is just so thin here for this terminal. I might get it. Okay, let's just connect power to this thing again and see if it's still jumping all over the place and see if I can get a reading off of it. Well, it's looking a little better than it was. Still not accurate, but at least now it says it's 80 hertz. It's supposed to be 400. Maybe my signal is too high. That might be, my signal level might be too high. Well, it's looking a little more promising. A little closer to what it's supposed to be. If I stop this and give it a 1400 hertz tone. No. I think I got this thing working. Not reading my audio generator perfectly, but when I transmit on my handheld radio, I got it on low power, so I'm not going to even hit any repeaters. But I'm going to transmit at 147.86. 147.86. Unkey.
Let's try 146.34.
Let's try
1-3. 1-1-1-1-1-1.
let's go to the
2-2-1-2-3-4.
let's go to the 220 band. 223.1. Looks like it's working.
5.
223.36. Pretty darn
6.
close. 222.36.
7.
146.12. I think it's working.
8. 9.
I'm just going through my channels on here.
2-2-1.
449, 425. Okay, it's a little bit off on that one. Be careful here. 148, 525. It's a little bit off on that.
2-3.
So it's not quite right. That should be 449.1. Well, this had a name, Datascan Instruments, stuck on the front of it. Whether that's legitimate or whether that's just what someone decided to call this thing, it sure looks like a kit.
Back to the audio generator. There's a 20 kilohertz signal, and it's showing 20 kilohertz. I just had the gate in the wrong position before. Let's try sending it, say, 10 kilohertz.
Now sending it a 10 kilohertz signal, and it's measuring 10 kilohertz. 5 kilohertz. Pretty close. So the gate has to be on slow. Put the gate on fast and I'm not going to get the right reading. It's going to show 500. See, when I got this thing, I never got any directions with it. As I say, I bought it at a flea market. Let's try 1 kilohertz. For fuck's sakes! Let's try 1 kilohertz. If my phone will stop blowing up. Showing 10. It's bouncing around a bit at 1 kilohertz. Let's try something slower.
Some people just don't get it. I tell them I'm
400
busy,
hertz. Would go down that low.
and they have to acknowledge it by sending another message. They just don't get it.
It says it's 10 hertz to 1.4 gigahertz, but the lower frequencies tend to give it some trouble.
Now, this may be just due to picking up radiation from all the inverters for the
20
lights.
hertz.
The lights and my LCD screen and my little FM transmitter that's behind me. It's probably just picking up induction from other signals in the air.
But yet when I give it 100,000 or 100 kilohertz, I should say, it's dead on or pretty darn close. I don't know how high this little generator goes. Let's try 500 kilohertz. Working on that one. 900 kilohertz. Will it go that high?
I have my generator set for 900 kilohertz now, which I think is well beyond what this little generator is capable of going to. It's showing. But the counter seems to be working now.
I don't know how high this how high this thing goes. I don't think this thing goes that high. The display does, but I don't think this thing goes anything higher than that. See, I'm pretty sure that this thing craps out. But if I turn this down, $499,999. Take it down to 250 kilohertz. Yeah, 250. So it's working. It just doesn't work on low frequencies. If I take this thing, say go down to what was I trying? Like 1 kilohertz. A little bit off on 1 kilohertz. So below that, it doesn't appear to be accurate. 2 kilohertz.
Now I'm also running this on a switch power supply, so that could be causing some
A
problems.
little bit off on a 2 kilohertz signal. I wonder if it responds any difference to the different types of signal I can give this, like a sawtooth. It's more accurate on that than it is on a sine wave. How about a square wave?
I've been thinking about it, and I'm thinking that this, on the lower frequencies, it's probably interference that's making the display do random things. Just interference in the shop from outside external sources.
So 2 kilohertz is off a little bit.
And possibly the ripple coming down on the DC line, because it is being fed with a switching power supply, and this thing was designed to run off batteries.
To say 500 hertz. Now I might switch this to, if I switch that to fast, will it be better?
Oh crap, now they're phoning me.
So as you can see, this thing is accurate for the higher frequencies, and I think what this thing was probably designed for was for checking radio transmitters more than checking checking audio, because let's say when I key up my transmitter beside it with a little antenna, I'm just putting a piece of wire on here, go through the pre-scaler. The direct would have been like for CB radios in the 27 megahertz band, and then up to 50 megahertz. And then beyond that, you use the pre-scaled input. But as you can see, when I flip it to fast, and I'm transmitting 222.7, it's showing 222.7. If I transmit 147.86, so it's working now. As I say, it's not the most accurate, I guess, in the world, but it is what it is. As I say, I bought it at a flea market years and years ago. 1991, I believe, was the first flea market I ever went to. 91 or 92, I forget. But I used to be more keen on going to ham radio flea markets when I first was licensed, because I was looking for equipment. I was looking for deals on equipment, and I got burned more times than I care to remember by the guys out there looking to make a quick buck, to prey on the new hams. Now this thing probably be more accurate if I put it in its metal box. We'll try that. I'll put it in the box, put the cover on it, and see whether it affects it at all, because I'm sure that having the shield on it will improve the accuracy. But yeah, I remember the first couple flea markets I went to, there was vultures there, because I got my license back in the day when, well, you still had to have code. I got my license just before they removed the code requirement, but the code requirement disappeared for VHF operations shortly after I was licensed, and there was a flood of new hams getting their tickets all about the same time. And anyway, those first couple flea markets, everybody was looking for equipment. I think all the old boys, they had dollar signs on their eyes. They had a captive market that was looking for used equipment that they figured they could get for a bargain, and it was kind of like the Wild West. It was kind of like eBay. I think it still is to a certain degree like that now at hamfest, because I've certainly seen enough equipment, enough old garbage selling for new equipment prices. You know, asking $200 for a Heathkit scope that was like from 1965. I'm not exaggerating. There was there's always some really high price gear. I've done well. I picked up that Tektronix 604 XY monitor scope, which I use for my oscilloscope clock. I picked that up for $20. But I also picked up a Heathkit, was it an HM10 waveform monitor or station monitor, and paid a lot of money for that thing, and it never worked properly. So it's and I bought a bunch of stuff at hamfest over the years, and say a lot of it never worked properly.
Channel mode.
147.86. Yep. 222.7. 449.425. I'm gonna trip that repeater again. This is on low power, but where I am, it's hard to hit repeaters from inside my workshop here, because I'm quite a ways away from most of them. From a handheld anyway, it's pretty tough to hit. Put an external antenna on here, no problem. Anyway, that's this thing. I'm not going to do any more on it. It's actually working, and it's working probably as well as it ever did. But I grabbed it out of the shack and brought it down here. It was not even turning on properly, but that regulator was loose. Anyway, I'm done with this thing. It's a lost cause, let's just say. Thanks for watching.